Hi, my name is Catherine Crockett and I'm going to be presenting two gas laws. I'm going to be presenting Charles' law and Gay-Lussec's law. First, I'm going to be doing Charles' law. You're going to need a heat-proof bowl or pot, a balloon, some string to measure the circumference of such balloon, a ruler in order to measure the string to determine the circumference, a calculator to calculate your results at the end of the experiment, water, and some sort of hot plate or stove. The first thing you're going to do is pour water into a pot. See, since I have a really large pot, we're going to be using quite a bit of water in order to make sure the heat convection remains the same throughout. The next thing you're going to do is you're going to need to blow up a balloon. You don't want the balloon to be so overblown because otherwise the volume won't be able to increase anymore. But you also don't want it small enough that it won't make an impact in the pot. Now you're going to take the temperature of the water in the pot. Then you're going to take the string and wrap it around the widest part of the balloon. This is so you can measure the circumference in order to find the volume of the balloon. So you're going to want to take your string and wrap it around the balloon. And then you're going to cut it where it overlapped. So this is my circumference. Now using the string I cut, I'm going to measure the length of it in centimeters in order to find the volume. So now I'm going to place the pot on the stove and turn the heat on the stove all the way up to high. I'm going to wait for this to boil, so this might take a few minutes. As you can see, the water is now boiling. So what I am going to do is I'm going to move it over to the sink. The reason I moved it over to the sink is because it has been known that really hot water can actually break latex balloons. So I'm going to wait for this to cool down, and then I will measure the temperature when I put the balloon in and then when I take the balloon out. The temperature is now cool enough for the balloon to be entered into the water. So I'm going to take the balloon out, the thermometer out, and put the balloon in. And let it sit for a couple of minutes. Okay, the thermometer reads 76.2. So I'm going to record that and take the balloon out. Now with the balloon taken out, I'm going to quickly measure the circumference so as to keep the heat. Right here and cut once again. Okay, here's the circumference afterwards. Okay. I'm now going to measure. It increased to 66.5 centimeters. So this is my temperature 1 and this is my temperature 2. Volume 1 and volume 2. As you remember, I found the circumference of both of these. So what I did was I divided the circumference by 2 pi to find the radius. And then once I found the radius, I cubed it, multiplied by pi, and then multiplied by 4/3 to get my volume, which is how I got these. As you remember, I took 2 different temperatures for temperature 2. I took one before I put the balloon in, and then once I took the balloon out. I found the mean of these temperatures to get my temperature 2. Okay. This is Charles' law, and I put it out like this. Now what I'm going to do is I'm going to find the theoretical yield, what it should have been. So that's 4478.87 over 298.5k equals x over 352.k. After doing the math and cross-multiplying, it is found that x should have equaled 5,292.12. Now I'm going to find the percent error. So I'm going to take what I got in the experiment and subtract it by my theoretical, and I get negative 326.04. I'm going to absolute value that, so that's 326.04, and then over 5,292.2. I'm going to divide this, and when I divide, I get 0.06169 multiplied by 100, give me 6.1609% error. And these are my calculations. I believe my percent error came from when I put the temperature from when I put the balloon in to when I took the balloon out differing, therefore having to use the mean. Also, I think I waited too long before I measured the circumference of the balloon, allowing the balloon some time to shrink. That was Charles' law. The next experiment I'm going to be doing is lussec. What you're going to need for this experiment is you're going to need a ball. I'm going to be using a ball in this one. I'm going to be using a pump that also has a pressure gauge on it to measure. You're going to need a tub or a bucket, some ice, water, a thermometer to measure the temperature, and a timer to keep track of how long you're going to be keeping the ball in the water. First thing you're going to need to do is measure the pressure of the ball. Next step is to fill up your tub with water. Now I'm going to take the temperature of the water. Now you're going to pour the ice into the tub. Thereby lowering the temperature. And then because I bought this yesterday, there is more water. Now because the ball floats, what I'm going to do is I'm going to put the lid on the tank to hopefully enclose the cold. I will look at this in about 1 hour. After 1 hour, you're now going to take the ball out and measure the pressure. Then you're going to want to measure the temperature of the water. So, the temperature one was 24.1 degrees Celsius. When you add that to 273, you get 297.1 Kelvin. For temperature 2, it's 16.2 degrees Celsius. Add that to 273 and you get 289.2 degrees Kelvin. For the pressure, I measured the pressure using the pressure gauge, and then I added 14.1 psi because you also have to take into account the atmospheric pressure surrounding the ball. When I did that, I got 22.45 psi for the initial pressure and then 21.2 for the final pressure. Now, since I have the final pressure, I'm going to find what the theoretical yield should have been. So 22.45 over 297.1 equals x over 289. By using cross multiplication, I have gotten x to equal 21.9. This is my theoretical yield. Now I'm going to find the percent error. So my actual yield was 21.2. I'm going to subtract that by my theoretical yield, and I'm going to get negative 0.7. Absolute value 0.7. I'm going to divide that by 21.9, which is my theoretical yield, and get 0.03196. Multiply that by 100, and my percent error is 3.196% error. The reasons I got this error might have been that I waited too long to take the pressure of the ball after removing it, or perhaps the temperature of the water rose significantly enough that the pressure in the ball didn't decrease enough. This has been my chemistry project. Thank you for watching.